Thank you, Thibaut, for having me here today. I'm happy to be here to share my findings with you from this past season. So, my primary interest and research is actually learning how, these heat waves that we have been seeing in the past years are only going to increase, and there's only going to be increased atmospheric demand for water, and we'll have increased population and more pressure on water resources. So it's very critical that when we think about these extreme heat events towards the future, that we continue to develop strategies. And as far as wine composition and wine quality, I'm going to talk to you today about an experiment I did to assess this. So this just gives you an idea of how much we would expect, number of days. So right now for CalAdapt, a climate or a heat wave is considered 3+ days over 38 degrees Celsius or 100 degrees Celsius. Really, you want to think about heat waves in the context of where you are locally. It's above, and it's an anomalous event. So you pick your current period, and if it's something that's above what your current period would be, it's going to be different on the coast than it would be in the Central Valley. But you can see there's a pretty striking increase in the number of days that we'll see above 38 degrees Celsius in the end of the century, mid and end of the century. And this is, so I'm going to take you to the Central Valley. Don't be upset. I know my research takes place in the Central Valley as well as in Napa. But for this experiment, I'm taking you to the Central Valley, which is actually, I think, a great place to look because an area like Lodi will experience a lot of the same things that may happen in other cooler regions, but earlier. So you can see the scale for the number of days above 38 is much higher. I'm going to take you to eastern Lodi for this experiment, near Galt, which actually does have some pretty high-end vineyards. But again, this just shows you how extreme the changes will be. So these are all things that you're relatively aware of. Some of these are inconclusive results, but if you do have these periods of above 100 degrees Celsius, depending on the developmental stage and how many you've had that season already and timing, you can have really different effects. So if this past year there's a huge heat wave during flowering in Davis, for example, and it can really have a huge influence on reduction in pollen viability and fruit set, even if you've had a really wet year. Also, throughout the season, there can be variation in stomatal response depending on the cultivar, but you generally have prolonged reduction in photosynthesis and then carbon assimilation. Reduced berry size and yield is common. Reduction in phenolic compounds, although there's some mixed results that people have found on that. Decoupling of the development in sugar and phenolic compounds, which is something that winemakers have to deal with. And then what's critical and what I'm very much interested in is how these vary in different genotypes or different cultivars. So I'll quickly introduce you to the vineyard and site that I was working at. So this is in collaboration with Gallo. This is Borden Hills Ranch out in eastern Lodi near Galt. These are about 9-year-old Cabernet Sauvignon vines. I think it's about 5 tons per hectare or per acre is the yield. The rootstock's 1103P, so pretty high vigor rootstock. It is high wire and it's all mechanized, except when we were doing our measurements and harvesting ourselves. And the great part of this vineyard, it's very heterogeneous, and we are able to take advantage of this variable rate drip irrigation system, where at 30 by 30 meter pixels, you can irrigate differentially. And so this is the design. Don't be bothered too much by the colors in the background. That's just NDVI, so basically how vigorous the canopies are early in the season. The reason you use this variable rate drip irrigation is so that you can actually balance out your vigor across a heterogeneous site, which enables you to have a more consistent yield and consistent product. So for our experiment, they were doing that early in the season. They were using this irrigation system to make the yield more consistent. And so within that, we set up 3 treatments, baseline, so that it was the deficit irrigation during veraison and post-veraison. and then 2 times the baseline, so 2 times 60% ET values. And we were estimating ET on site using both surface renewal and then also satellite data, Landsat data. And then 3 times baseline, which ends up being a lot. I mean, that was watering almost 24 hours a day when you're at 3 times the baseline. And that obviously depends on your irrigation system, but in Napa, it's not feasible in many vineyards to actually even irrigate that much. So this is a very wordy, verbose list, but I just wanted to give you the idea of how much we were out there measuring and what we did measure. And also, I should say that this project is my master's student's project, Martina Galliano. She's a winemaker from Tepiz in Mendoza, and she's phenomenal. And she helped orchestrate this entire sampling effort. So as I said, there was variation in pre-treatment irrigation only to even out vigor, and you'll see that in a second. And as far as our treatments, we changed the levels of irrigation 1 day before the heat wave, during the heat wave, 1 day after. This was based on conversations with growers, which is pretty typical. You start dumping water on when you see the heat wave coming. Pretty much regardless of the current status of the plant, I would say that people do this. And then from there, we're doing weekly diurnal measurements of water potentials, both pre-dawn, midday, stem water potentials, gas exchange, fluorescence data to assess stress, and leaf temperature. And we did this from mid-July through September. And then we did this every time there was a heat wave. We'd do one prior to the heat wave, during the heat wave, and then look at recovery after. And we also, from 50% veraison on, collected berry samples for chemical analysis until harvest. And I should say, too, we harvested and produced wine lots, which we have the beginning wine chemistry on, but all of this will be taken to sensory analysis in the spring. So this is just an illustration of the treatments here to give you an idea. This is on the y-axis on the right is daily maximum temperature, so you can see where we hit that 38, 40 C over 100 degrees Celsius for multiple days. This is the baseline watering, irrigation, and then this was heat wave 1, which happened the end of July, beginning of August. So that was just about 50% veraison or prior to, well past fruit set. And then the second, if I can get this, the second was during maturation. And so that was around August 13th to 15th. And harvest occurred around the 23rd, to give you an idea of the season. So as far as physiological responses, many people look at stem water potential, midday stem water potential to assess stress. And so as you can see, so for the rest of this presentation, this orange or this yellow color will be the baseline. That is 60% ET. That's maintaining deficit irrigation regardless of heat. Then the green is going to be 2 times that amount. The purple is 3. So purple is the most well-watered. So you can see in the first heat wave, there really isn't an effect. They were pretty stable at a -10, -12 bar, not very stressed. And actually recover really well after the heat wave because there's a ton of water dumped on. And only afterwards do you see some effect of there being a little bit more negative stem water potential, but not severely stressed. In the second heat wave, it's sort of a similar finding. You do see a reduction in the baseline, but I wouldn't say it's enough to be alarmed. So really looking at this stem water potential, you would, depending on how conservative you are, I wouldn't say that this exhibited tons of stress. So I'll walk you through this. There's a lot of graphs here. So I'm going to show you only heat wave 2 for the rest of this, just because it's not, heat wave 1 was similar. But what I want you to see here is heat wave, post-heat wave, and recovery, that this is net photosynthesis. There's reduced carbon assimilation in the baseline, but there is recovery. And similarly, you have higher or lower stemmatal conductance meaning, and that links directly to reduced carbon assimilation, but you always have recovery. Similarly, what you want to do is cool the plant down. So you want to look at leaf temperature and how much are you cooling that plant down relative to net photosynthesis. And again, the baseline is significantly different, and you're having much reduced photosynthesis, and you're getting to leaf temperatures up almost to 50 degrees Celsius. And you have a lot of cooling effect from irrigation. So it is extremely effective of bringing your leaf temperature or canopy temperature down, sometimes up to 8 or 10 degrees. So irrigation is useful in that way. But I should note here too, you actually don't see a big difference between the 2x and 3x as far as how much it's cooling. So in terms of yield, this is what would be to be expected. The deficit irrigation has reduced yield both in terms of kilograms per vine and grams per cluster. No difference between 2x and 3x. We harvested at 25 bricks, and in the baseline treatment, you see that it reached 25, the sugar accumulation happened more quickly, you reached 25 bricks more quickly, and that you actually had higher sugar content throughout this whole period due to the heat waves. Again, the baseline, higher pH, lower TA. This mirrors what has been found in the past. Which I think is really interesting is how striking the anthocyanins are in differences, and that your reduced anthocyanins, which is significant all post-heat wave through harvest, is that actually the baseline and the 3x treatment both have a reduction in anthocyanins and depressed phenolics. And it's your 2x that seems to be doing the best in terms of that. So all of a sudden, you don't have this added benefit of dumping on that much more water, it seems. And similarly, you see the same thing when you look at the decoupling of anthocyanins and sugars. Again, and this mimics what we saw before. Again, this is your 2 times baseline, and then you move down in terms of having lower anthocyanins for a given bricks level. And so you see this decoupling where the 3 times baseline and the baseline, you're suffering in terms of accumulating the anthocyanins you may want at a given sugar content. Tannins, this is something we're trying to tease apart a little bit more now. So as you know, tannin synthesis happens much earlier, happens at fruit set, even at flowering, you start seeing upregulation for tannin synthesis. And so it was really interesting to us, because we did not sample berries prior to this, that even before, that first heat wave had some sort of influence on either tannin degradation or synthesis, and it was maintained throughout the remainder of the season. And it was, again, same thing, baseline had the least, then that 3 times versus the 2x baseline. And just quickly to summarize, so we did see some negative physiological effects. Although we know too that you might want reduced carbon assimilation in some cases, so it's not necessarily negative, but you just have reduced photosynthesis, stomatal conductance, but you did have the positive, having the more water, of reducing the leaf temperature in the canopy, and this would be mimicked by misting. I'm also doing some other work in looking at how misting might affect these properties. But still, you have that higher bricks in the baseline and that decoupling, lower anthocyanins, tannins, and then also, as I said, that 3 times baseline, you also seem to see that depressed phenolic concentrations and compounds. So as far as major conclusions, and this is just the first year of this study, so it's a longitudinal study and we'll be continuing on. There really seem to be negative effects on berry chemistry and plant health from both under and overwatering, which means we can't just go and dump a ton of water when we see high temperatures, especially as these increase, that it will have negative effects on really important parameters and qualities of your wine. And then also too, just because you see recovery from physiological stress, it may not necessarily mean that you recover in relevant berry biochemical traits. And so Next, we'll be doing our wine sensory panel. And I should say we've tasted these wines already. They are very distinctly different. It definitely makes a difference, these different treatments. And then in year 2, we'll be doing a lot more adding in sensors where we approximate sensors within the canopy and link it to some towers and remote sensing to have different means of looking at stress, both ET, infrared, and using solar-induced fluorescence for detection of stress. And then we're going to look at carryover effects. So when we did have those depressed photosynthetic rates, does that in turn affect yield in the subsequent year? So we'll have a nested study. And yeah, lastly, I am actually setting up an experiment to do heat wave manipulations based on these preliminary data. And then have common gardens in Napa and Davis. And I'm really interested in this notion of acclimation ability, which was spoken to earlier, is what does it mean if you don't have the heat in the beginning of the year? How plastic are these different varieties? Does it really help to have it, and how much does it? So doing controlled experiments in that realm. And with that, I'd just like to thank my collaborators, my lab, and funding sources. And thank you so much for having me here.